Hi folks, you're with the SPS 2015 in Nuremberg. My name is Martin Schulz and it's not too difficult to spot. I'm with Infineon Technologies. Infineon Technologies on the SPS showed up with this demonstration. This is a 3D printing device and it's an application predestined to show the power that Infineon components can bring to your application. 3D printing typically is a motion control application. Motion control comes with driving stepper motors which need power electronic and powerful microcontroller to do the trick. In our application, we use the Novalytic integrated circuitry, a half bridge that's well capable to provide far more than 10 amps, which allows the opportunity to parallel motors on the power side. This is beneficial for 3D printing because for the higher performance you want two motors to be controlled, but with a single driver only there's no risk about delays, about different pulses, or about failures in a single channel. In case the motor really would fail, the motors would fail synchronously and fall back to a safe situation. In case there will be two channels, there's still the option that only one channel fails and one motor moves while the other does not, or in a worst case scenario moves in the wrong direction. This way there would be high mechanical stress to the printer itself, risking damage or even destruction of the device. In our case, the Novalytic ICs would be well capable to provide 20 amps to each of the motors, allowing the integration of even larger machines. Regarding this, which would be sort of a desktop printer, there are far bigger machines out there in the industry, and the motors would easily grow from 2 amp per winding to maybe 8 or 10 amp, and then the need of paralleling would still occur to increase performance. This is well possible with the approach we did. On top of the board you can spot the XMC2Go. We used this demonstration and evaluation kit to make the indexer for the stepper motors. This allows to software configure the stepper motor. So instead of having the opportunity to have a certain micro stepping, usually given in quantities 2 to the power of n, the software approach allows to not only have 2 to the power of n micro steps, but any number of micro steps. So this motor with physically 200 steps per turn can easily be tuned to do 1000 steps per turn, which is a fifth step, which on traditional hardware indexers is not possible. This allows to even better choose between high speed of the drive and high accuracy and high resolution. In the setup given, we use a 16 step and get a resolution in X and Y of less than 3 micrometers, and in Z the resolution is ridiculously high, even far below 1 micrometer. In theory, practically, maybe 1 to 2 micrometers is feasible. The whole device has a highlight, which is the Optiga Trust demonstrator. So to protect the printer from bad or low quality material being used, the material is qualified and authenticated, very similar to ink cartridges that you're used to see on ink printers. So once there's an authenticated filament in use, there's a green message saying that the world is okay. If there's no filament in use, okay, then it's not a qualified one, but the non-qualified situation remains even if a generic spool of filament is used. Once the coil is given to the display, it only takes this way. It only takes the processor just a few cycles to detect the certificate, which is encrypted into the Optiga Trust E solution, switching from red to green light and telling you everything's okay. For the end user, the benefit is the knowledge that you are working with high quality material. For the manufacturer of the printer, it's important to have a proof in case of warranty that maybe the failure is not in the printer but in the material in use, and it's easy to relate this to a non-authenticated material. A 3D printer is iconic. So from the desktop printer out there that you see here, this is a small device. There are bigger entities that today also started printing bicycle frames, bodies for cars, and in China we already saw applications where walls for houses have been printed in a 3D printer equipment. Of course, this tends to be far bigger, and then stepper motors might be replaced by servo drives as well. In essence, this is the perfect application for Infineon components to bring high performance and high quality reliable systems to the world of 3D printing, and the demo is here for you to check out.